This report is a summary of progress in Atlas development during July, August, and September of 1957. It covers the highlights in production, research, development, and testing at the contractor's main plant and 6 other locations where major tasks were accomplished. At the Point Loma facility, engineers were conducting a variety of tests, which contributed toward a high degree of element design refinement. At Sycamore Canyon, construction was basically complete at the S2 site, while at S1, pre-flight evaluations with Missile 3A were finished and preparations made for start of research and development with Missile 9A. The program was advanced at Edwards Rocket Base with progressive missile tests, while Stand 1-4 was being modified for initial testing of B missile systems. At the Air Force Missile Test Center in Florida, the flight test program gained momentum with the second launching of a missile. The major task in development of Project Atlas is accomplished at the contractor's San Diego plant. This is the final assembly and checkout area on August 21, midway through the quarter. This area is the terminal point for the manufacturing task. This missile is A-Series bird number 8 in final checkout. Consoles are in use to evaluate components, systems, and integrated systems. 8A will be held at the San Diego plant for detailed factory and engineering evaluations. As an engineering tool, this article will be accessible for developmental studies. B-Series missiles are now in final assembly. Numbers 1 and 2 are seen here, upper left and middle, adjacent to A-Series number 13. B-Series missiles may be identified by the different nose configuration and by the addition of the center or sustainer engine to the aft cone. Booster sections will be attached to the B missiles by means of powder-actuated fittings. In flight, the thrust section will be jettisoned after 120 seconds of flight. Second stage flight will be powered by the sustainer and vernier engines. Missile 3B was moved into final assembly August 31. On September 25, Secretary of Defense Neil H. McElroy spent the day inspecting Convair government projects. Among visitors to the San Diego plant during the quarter was Air Force Secretary Douglas. Secretary Douglas arrived on August 30 to inspect the contractor's manufacturing facility. The inspection included briefing and conferences on the status of defense projects. In July, engineers from the Astronautics Reliability Group conducted a month-long research project at March Air Force Base. Objective, to establish confidence in proposed training procedures and to conduct developmental work toward refinement of equipment design. Basic objective was to determine human factors connected with the transfer of hydrocarbon and liquid oxygen propellants from remote storage tanks into Atlas missile tanks. Concept of this project is to provide a statistical basis for designing the machine around the capabilities of the operator. An evaluation was made of the ability of Air Force enlisted personnel to learn the fundamentals of the propellant handling system and its operation in a short time. Each man spent 8 hours in classroom instruction and 6 hours in individual operation of the consoles. This is an operational mock-up of the liquid oxygen and fuel tanking consoles, designed for the first ballistic missile base at Camp Cook, California. Members of the engineering department of Convair Astronautics acted as instructors and observers. Graduate psychologists, their group is called Human Engineering. 2 sets of consoles, designed by Arthur D. Little Corporation, were used for this study. Both perform the same function, but present different arrangements of the indicator lights. The The contractor's Point Loma laboratory is located on a peninsula near the entrance to San Diego Bay. Here, engineers conduct tests of a hazardous nature. A standard production missile tank was transported to the point on July 29. Engineers at Tower A will conduct studies of propellant loading for B-series liquid levels. They seek specific information on characteristics of liquid oxygen and fuel within the environmental conditions of Atlas missile and ground support systems. At Tower E, a series of tests was initiated to verify proper separation of the booster compartment from the missile. A production thrust section was installed during the quarter. It is attached to a stub tank, which duplicates the aft section of the missile. Instrumentation has been set up to record sequential timing and motions in the 3 axes. The technician is calibrating the linear movement transducer. Engineers will evaluate drop tests to establish reliability of separation components. Initial tests involved a 6-inch drop. Data verified the proper separation of connector fittings and quick disconnect valves that supply propellant and power to the booster section. The 10 powder-actuated connectors must react simultaneously. The test rig is designed for a maximum drop of 15 feet. During the quarter, an additional stand was completed for testing the accessory power supply. The APS unit occupies the same relative position on the stand as it does on the missile. The cone at the top of the test rig duplicates the aft end of a missile tank. Tests are remotely controlled. Initial tests provided information on compatibility of the unit with actual missile hardware. Records were obtained on propellant utilization, heat, vibration, and output of AC, DC, and hydraulic power. An automatic programmer will provide a varying load for the unit, which will be compared with actual performance. Conversion of the Point Loma facility to B-series missile testing is almost complete. Research and development will be phased to support the overall objectives, providing reliability and confidence in each component of the system. Construction of the new astronautics plant, while delayed due to strikes and other factors, is progressing. Work is well underway on all major items, including the 6-story administration building, the reception building, 6-story engineering building, engineering laboratories, and the 500,000 square foot manufacturing building lower right. Assistant Secretary of Defense William H. Holliday visited the new facility on July 26. Secretary Holliday and party inspected a model of the plant and toured the construction area. First buildings to be completed will be sections of the engineering laboratories. The new facility will be in full use by early 1958. Sycamore Canyon is located on the Camp Elliott Marine Corps Reservation. In the foreground is the administration building, and to the left, storage and shop building. S2 is the second static test site to be constructed at Sycamore. It is to be used in testing the initial B series and later advanced designs. The site was made available to contractor personnel in mid-July. Preparation for functional use of the area began with installation of test support equipment and checkout of facility items. The Air Force granted official occupancy of the facility on August 30. On August 30, 9A was delivered to Sycamore Stand 1. 9A will be used as a research static test article, utilizing vernier and booster engine firings to evaluate and develop components and systems. Edwards Rocket Base is located on Lumen Ridge in California's Mojave Desert. Here, Atlas development was carried on at 3 test sites allocated to the project. The program at Stand 1-4 for A-series missiles was completed early in the quarter. Two 4-second firings were conducted to obtain data for evaluation of engine starting characteristics. Operations were then suspended to permit modification of the stand for scheduled tests of B-series missile systems. Changeover to Series B hardware requires extensive revision of the stand and blockhouse equipment. Instrumentation must be provided for additional systems. The accessory power supply unit is one of the systems being installed for compatibility evaluation. The unit includes an airborne load simulator. The load simulator will be used on first flight tests of the APS unit. Installation and evaluation of the power unit is under supervision of American Machine and Foundry engineers. On September 19, the B thrust section for Stand 1-4 arrived at the desert site. Delivery was to the assembly building, where it was readied for installation. Mating of the unit to the battleship tank will be accomplished early in the 4th quarter. The second Atlas facility at Edwards Rocket Base is Stand 1A. Static tests here progressed from an early 30-second run to a full duration firing, accomplished near the end of the quarter. The major task during this period was to provide performance data in support of the second flight test at AFMTC. Firing 108 was set up to meet this objective. This is the vernier engine at start, followed by booster ignition 5 seconds later. The run was scheduled for 80 seconds and accomplished at noon on September 10th. More than 400 channels of information were recorded during the test. Primary objectives were evaluation of airborne pneumatics, a new heat exchanger design, heat radiation shield, and thrust section purge system. Secondary objective was to continue observations and record data on all ground support and airborne systems. Run 108 continued for the full scheduled period of 80 seconds. On September 26, engineers and technicians were preparing for the first of 3 full-duration runs of Missile 2A. The heat radiation shield and asbestos boot were installed for further evaluation. General Electric engineers set up to obtain data on environmental conditions and performance of guidance equipment. Stand 1A, September 27, Run 111. First full-duration firing at this site. Information obtained during this and subsequent tests with Missile 2A will provide statistical data for determining the reliability index of the Series A missile. The data will be used in a study of the endurance capabilities of integrated missile systems. Run 111 was terminated by the flight programmer after 127 seconds of successful operation. Latest addition to rocket-based facilities is Stand 1-1. Major emphasis of tests here has been on the resolution of flight problems. The configuration of Missile 5A includes a modified General Electric guidance antenna. An environmental evaluation of this component will be made during hot runs. The vernier flame deflector at this stand is copper-lined. One objective of Run 107 was to determine the ability of this item to withstand vernier flame impingement. The plate behind the vernier is a blast shield, which has been added to all static test stands. Special camera installations have been mounted around and inside of the thrust section. The first shot you will see of Run 107 will be from one of the cameras mounted inside of the thrust structure, looking toward the flame deflector. Run 107 was the final test of the quarter, accomplished on the last day of the quarter. It was a 30-second vernier, 25-second booster firing. Data provided backup information for AFMTC in 2 areas. An investigation of possible causes of fire and a preliminary analysis to determine the most reliable method of fixing launch weight. Flight tests of the Atlas missile are accomplished at the Air Force Missile Test Center. Here, progress toward flight testing is initiated at buildings J and K, Missile Assembly and Administration Center. This is Missile 10A, third flight article, which arrived at AFMTC July 19. At this site, each missile is subjected to inspection, checkout of each component, and performance evaluation of integrated systems. Preparation for flight includes accurate determination of weight and center of balance. This is Missile 6A, second flight bird, delivered to AFMTC during the second quarter. Weight is determined electronically, one of the final tasks accomplished at the assembly building prior to erection of the missile on the flight test stand. Highlight of the quarter occurred as a culmination of research, development, and tests at the 4 Atlas facilities. This is Complex 14, site of the first flight test. Missile 6A was erected in the service tower on August 2. Engineers made final preparations for flight. The many items of ground support equipment were calibrated, checked for function, integrated into a unit. All systems were run as a unit and checked out satisfactorily with a static firing on September 20. On September 25, everything was in readiness for the second flight test. These were the objectives: to determine thrust and impulse, propellant feed characteristics, reliability of the airborne pressurization system, environmental condition of propulsion during flight, missile structural integrity, and to establish performance characteristics of the flight control system. Liftoff occurred at 14:57 hours. Launcher release was excellent. Missile attitude and stability were successfully demonstrated by autopilot performance during initial phase of flight. However, a 17-cycle gimbaling frequency corresponding to the third bending mode of the missile airframe was evident from telemeter data. Vibration and autopilot frequency response tests in the region of 17 cycles will be conducted during the fourth quarter. Propulsion, airframe, electrical, and pneumatic systems function normally until 32 6/10 seconds after first motion. At this time, a propulsion system failure occurred, followed by a complete loss of thrust 3 seconds later. The pieces seen falling from the missile after loss of power were sections of the DOVAP antenna and associated parts. These were peeled from the missile by aerodynamic forces incurred in the violent maneuvering. At the time of shutdown, the missile had attained an altitude of 9,700 feet and a velocity of 660 feet per second. Maximum altitude of 16,300 feet was reached at 52 seconds. The immediate cause of shutdown was the loss of liquid oxygen regulator reference pressure. This resulted in approximately 70% decrease in liquid oxygen flow to the gas generator. 3 seconds later, the gas generator shut down completely, probably due to flameout caused by the excessively rich fuel mixture. A command destruct signal was transmitted by the range safety officer at 63 6/10 seconds after first motion. Altitude 14,300 feet. Some modifications have been made in missile design as a result of the first 2 flights. The aluminum radiation shield will be replaced by a shield capable of withstanding flame impingement and relocated 31 inches forward. All structure aft of the shield, except for nacelles, will be removed. This will provide insulation and a free airspace protection from possible exhaust flame impingement. Critical aluminum plumbing will be changed to stainless steel for strength and resistance to vibration. The third flight missile is 10A. For the third flight, recoverable motion picture cameras will be mounted inside the thrust section. 10A is scheduled for flight test in November.